The problems that I'm going to do in this video are coming from the 7.4 class worksheet that I gave you a couple of classes ago. So you don't have to recopy the problems, they're already on the paper. We had done this one in class, but a student had showed me a second way to look at this problem and I liked it better. It was less confusing than how I had originally approached it. So I'm going to go ahead and do it again for you. So angle CDB is 6y. Remember, your middle letter is the one that matters, so that is 6y right here, CDB. And then ACB, which is here, is 2y plus 10. Now, from here, if this is 2y plus 10, then this over here is also 2y plus 10. If this is a right angle, then this is also a right angle. So what I've done is created a right triangle where you have the two acute angles of 6y and 2y plus 10. And we're going to use the properties of a right triangle and say the two acute angles in a right triangle are complementary. So what that means then is we can take those two measurements, add them together, and set it equal to 90. So 6y plus 2y plus 10 equals 90, giving you 8y plus 10 is equal to 90. And I don't know why the plus sign came out so weird right there. Subtract 10 from both sides of your equation to get 8y equals 80. Divide by 8 and you get y equals 10. But the question is asking you for the measure of angle ACB. So we need to take this 10 right here and we need to plug it in for y right there. So the measure of angle ACB is going to be equal to 2 times 10 plus 10, which is a total of 30 degrees. All right, going on to the second problem. So AE is 24. I'm going to go ahead and use the highlighter tool to indicate AE right here is 24. And then AB is 25, and that's this right here. And what they're asking you for is for this piece right here. Well, if I go ahead and isolate that information, we have a right triangle, B, E, A, and E is your right angle. AE is 24, AB is 25, and we're looking for this side here. Well, since you have two sides and you're looking for the third, we're going to use the Pythagorean theorem because you have two sides. So have two sides, find third. Okay, so this one is your hypotenuse because it's across from your right angle. So we take x squared plus 24 squared and set that equal to 25 squared. So remember that's your a squared plus b squared equals c squared. So we end up with x squared plus 576 equals 625. Subtract 576 from both sides of your equation to get x squared equals 49. So x squared equals 49. Take your square root of both sides of your equation so that your square and your square root cancel, leaving you with x, and you get 7. And since 7 is what our information is asking us for, we go ahead and write our answer there, and we are done. All right, now in number 4, so this one is giving you AD is 2x plus 4, so that's this right here. And then that CD is 4x minus 4. Well, we know that a rhombus has 4 congruent sides. So what we're going to do then is just take our 2x plus 4 and set it equal to 4x minus 4. So subtract 2x from both sides. I like to move smaller to larger. You can move whatever you want, it doesn't matter. Add 4 to both sides of your equation here to get 8 equals 2x. Then we're going to go ahead and divide by 2 to get x equals 4. Now, x is 4, however, we're looking for the perimeter of the rhombus. So we need all of the side measurements. So if we find one side measurement, we can get all of the side measurements. So 2 times 4 plus 4. So all I did was take this 4 right here and plug it in up there. So AD equals a total of 12. Well, if one side length is 12, so if this is 12, then that means this is 12, this is 12, and this is 12 as well. And then when you add all of those together, so 12 plus 12, whoops, that's not 2 at all, plus 12 gives you a total of 48. 8. Okay, so now for number 5, BE is 4x, and this is actually supposed to say AE, so go ahead and correct that on your paper. That was definitely my fault there. So AE is 4x, and AC is 10x minus 6. So I'm going to go ahead and just draw a line like this, and I'm going to put A here, E right here, and then C down here. So AE is 4x, and then this whole thing of AC is 10x minus 6. Well, we know, and even in our picture, that this is congruent to this here. So if this is 4x, then so is that one. And together, AE plus EC equals AC. So I'm just going to substitute in the values. 4x plus 4x equals 10x minus 6. So we get 8x equals 10x minus 6. I'm going to go ahead and just move, since this 6 can stay, I'm going to move the 10x to the other side by subtracting it. So we end up with negative 2x equals, don't forget to bring this negative down with the 6, and then divide by negative 2 to get x equals a positive 3. But the question is asking you for the length of AC, so we need to take this 3 and we need to plug that in for x right there. So AC is equal to 10 times 3 minus 6, which gives you 24. So that is the length of diagonal AC. All right, number 6, when both diagonals are drawn in a rhombus, it creates 4 blank. And now look at your triangles. We have right triangles, yes, but we also have congruent triangles. So I'm going to go ahead and say right and congruent. Those are both things that happen, and all 4 of them are exactly the same. All right, now number 10. So this time we have a square, and you'll notice it's standing straight up now. We've got 90-degree angles, and the angles are bisected, and that is really important to remember. So they are bisected by the diagonals. So making sure that you know that. And because of that, and the way that this works, that makes all of these individual angles here 45 degrees. So every single angle is exactly the same. So we end up with 45, 45, 90 right triangles, which you've seen before from back when we were doing trig. So ZVX, that would be the angle starting at Z, going to V, and then up to X right here. So it's this angle right there. Well, you notice that I already labeled it as 45, but it's also 3y minus 9. So that means then I can take this 3y minus 9 and set it equal to 45. Add 9 to both sides of your equation to get 3y equals 54. Divide by 3 on both sides of your equation, and you get y equals 18. And that was all it was asking for, is y, so you just go ahead and plug in your y and get, or I'm sorry, you don't have to plug in your y, you just get y is 18, and you're done. All right, now in the next problem, we have information about our diagonals. So let's go ahead and move on to there. All right, so this one, ZP is 4x minus 6, so that's here, and then PC is 2x plus 4. So I'm going to pull this out of the picture and just redraw it and label it with what I need. So ZPC. The diagonals are congruent to one another and they bisect each other. So ZP is 4x minus 6, and this is 2x plus 4. Well, they are marked as congruent, and therefore we can set them equal to each other. So 4x minus 6 equals 2x plus 4. Subtract your 2x from both sides of your equation to get 2x minus 6 equals 4. Add 6 to both sides of your equation, and you get 2x equals 10. Divide by 2, and you get x equals 5. Now, go back and double check what information it's asking for. It's asking you for Vx. Well, we know that the diagonals bisect each other, but also they are congruent and are congruent to one another. So if we find what ZC is going to give us the exact same measurement as Vx. So all I'm going to do then is take this 5 here, and I'm going to plug it in here, and then I'm also going to plug it in right there. So 4 times 5 minus 6, and 2 times 5 plus 4. And if I did this correctly, I would get the same measurement. So here I get 20 minus 6, which is 14, and here I get 20 plus 4, which is also 14. So I know we're good. But ZC is that whole measurement, 14 plus 14. So we end up getting 28 as our full measurement. And so all I did was just plug it in there and then add the two pieces together. All right, one more, number 12, and then we're all done. So XP is 20, so that's right here, and we want the perimeter of the square. So what we need to do is somehow get this measurement right here. That's what we need, right? Well, we know that if that's 20, then this is also 20. And so what we have here is a right triangle. See this right here? Where we have two sides and we need the third. Well, we know then that that means we need to use the Pythagorean theorem. So I'm going to go ahead and redraw this just so you can kind of see it a little bit better, hopefully. So right triangle here, this is 20, this is 20, this is what we're looking for, and this is XPC. So this one is your hypotenuse. So 20 squared plus 20 squared equals x squared. So we get 400 plus 400 equals x squared. So we get 800 equals x squared. You take the square root of both sides to get rid of your square. And the square root of 800, I'm going to go ahead and round to the nearest tenth. It comes out to about 28.3. So I'll remind you that I rounded to the 10th. Okay, but that is only one side. And it's asking you for the perimeter of the whole thing, and so that means we have 4 of them, all 4 sides, so all 4 sides are congruent, which means we have 28.3, and we have 4 of those sides, and that will give you a total of about 113.2. So 113.2 would be your perimeter of your square. Okay, if you have any questions, go ahead and let me know, and you can try the other problems and, go ahead and ask on those too, and I will see you soon.